All right, section 1 for circles is all about just the building blocks. So it's mainly going to go over some of our terminology. So first off, what is a circle? A circle is a certain figure that's created by the set of all points the same distance from a given center. Now, that might seem a little bit goofy what that means. If I call this red point the center, and I try to draw a circle is all of the points that are going to be the same distance from that center. So all of these points around here, and there's an infinite amount of points. All of these are just a little bit shorter, or a little bit, smaller away from each other, but they're all the same distance from that middle point. So in a sense, it's kind of like a polygon. It's kind of like one of our other shapes with sides, but you'd have to think of it as there's infinity number of sides. Okay, none of these make a straight line kind of a side here. We don't have any straight line sides like that or like that. They're so small and there's so many of them that there's an infinite amount of all of those sides. So the only way to describe a circle is that it's all of the points that are the same distance from this center. If this is our exact center spot, everywhere on here, it's the same distance away from that middle point. What is a chord then? A chord, I'm going to use a blue line here. Chord would be something like this. It's a segment with endpoints that are on the circle. So right here and here are my endpoints of this line, this segment. They're on the circle, so that would be called a chord. A diameter then, using green, is a chord that happens to go through that center. The diameter has endpoints on the edges there on the circle. It would go through the middle of the circle. Something else we know about diameters, they're always going to be twice the amount of the radius. So what is a radius? I'm going to do that one in orange. It's going to go from the center to the edge. So a radius is a segment with endpoints on the center and on the circle. So one here, one here. This radius is always going to be half the length of the diameter. And a tangent line, the last one we've got here. If I have a point out here, I can draw a tangent line, right, something like this. It kind of just grazes by the circle and only touches it at one point. So a segment or line that intersects the circle exactly one point. If I were to grab that line again and move it, something like this, now it's not tangent because it's touching here and here. You have to move it so it looks something like this. It's only touching the circle at one point. That would be a tangent line. One thing about circles, we always name them by their center. So if I called this center point here C, we would call it circle C. All of these other pieces, the chords, we name them by the endpoints. So if this was A, this was B, we'd call it diameter AB. If this one here, we called it H, we'd call this radius CH or HC, either way. A couple other things to look over. The circumference is the distance around a circle. If we're thinking of shapes, it would be, in a sense, it's like the perimeter. So for our polygons, we just added up all of the sides together. This one, you can't add up all the sides because there's an infinite amount of them. So there's another way to do it, but it's the distance that goes around a circle. If we call the length of our diameter length D, and the length of the radius is R, then we can call the circumference, C here, C equals pi times the diameter, or remember the diameter is twice the length of the radius, we can call the circumference pi times 2 times R, because 2 times R is the same thing as the diameter. Also, the area of the circle. The area is just the space within inside of it. The formula for the area, A, or area of it, equals pi times the radius squared. So radius times radius. Let's look at some examples here. If we look at this diagram, how would we name this circle? Remember, circles are always named by their center. This one right here, we'd call it circle H. To name a chord, I'll use red on this one. To name a chord, they're both going to start at A. This one goes A to B. That's one way we can name one of the chords. Another one we've got here is A to D. So our two chords, either AB or AD. Those are the two chords that we see in here. Name the diameter. I'm going to do that one with light blue here. Diameter is the chord that goes through the center. There's only one diameter drawn on here. And that one would be BD. From here to here, that is the diameter. Name the radius. This one might be kind of hidden. It's drawn twice, either H to B, that would be considered a radius, or H to D. That one could also be considered a radius. So either one of those, HD or HB, those are both considered the radius of this circle. And the tangent line, so it's the line kind of on the outside here that only touches the circle at one spot. This line right here, obviously that is line EC. This line will continue on forever and it only touches the circle at one point. For the next example, we need to find the length from Q all the way to T. Do that in red here. This length, if we knew that RS was 4, so this one in here is 4, and that P to S all the way over here, so this whole diameter was 16, and this whole diameter from R all the way over to U, this whole diameter was 22. Well, since PS is a diameter, that means that the radius, remember, is going to be half of it. So from Q to S, this one is going to be 8. From here to here is 8. Well, if it cuts off right here with this part being 4 and the whole thing being 8, that means QR has to also be 4. Because these two have to add up to make 8. Also, if R to U, this one is a diameter going all the way across. That means the radius, RT, from here to here, would have to be 11. So I'm going to say from here all the way to here has to be 11, which means if we cut off right here, at wherever S would be, 4 plus this amount would have to be 11, so this piece is 7. So we've got this one is 4, this one is 4, this one is 7. Get rid of the rest of that. So QT, this whole length that we're trying to find, is QR plus RS plus ST. QR is 4, RS is 4, and ST is 7. Add them all up, and from Q to T it would be 15. Let's look at another example. You can always leave lengths in terms of pi. So if your diameter is 13, you would just say the circumference is 13 pi. Or you can actually multiply it out using pi as 3.14. So remember, circumference we can either write as pi times the diameter or pi times 2 times r. So in this case, if the diameter is 16, we would say that the circumference, C, is pi times 16. And again, you can either leave it like that, say it's 16 pi, or you can use pi as 3.14 and multiply it on a calculator, and you would get 50.24. That would be your circumference. For the next one, if the circumference equals 24 pi, what is the radius? Well, remember, this formula has a circumference and a radius in it, so we're going to use that one. We also know that we were given that it was 24 pi, so we'd say circumference equals 24 pi, but it also equals pi r squared from over here. So essentially, we're just kind of ignoring that part. We just need the 24 pi equals pi to r. From there, we can divide pi from both sides, and it basically just cancels that out. So we would have 24 equals 2r. The same way, we can divide 2 from both sides. Gets rid of that. And we're dividing that one by 2, so it would become 12. So 12 equals the radius. A couple more terms here. Concentric circles are coplanar circles with the same center. So like before, I'm going to draw a center right here. And if we wanted to make two different circles that have that same center, so I'll make this one a little bit bigger, this one a little bit smaller. These two circles are concentric. They have the same center. Inscribed figures. So like an inscribed polygon here. That's just, I'm just going to delete that. A polygon whose vertices are each on the same circle. So notice each of these corners of the polygon, they're all touching the edges, or they're all right on this circle. Every single one of them. None of them are too far outside, none of them are too far inside. They're all right on the same exact circle. So we would say this pentagon, because there's 5 sides, this pentagon is inscribed within the circle. Kind of similarly to that, circumscribed is a polygon whose sides are each tangents of the same circle, meaning each of these sides intersects the circle at only one point, right here, here, and here. So it's like the circle is now inside of the figure. That figure is outside of the polygon. It is circumscribed. It goes around the circle, essentially. Inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Every single time, this will always hold true for any 4-sided figure inside. So all of the vertices have to be touching in the circle. So in our figure that we have here, angle D plus angle B, so this one and this one would have to add up to 180. And angle C and angle A would have to add up to 180. Okay, the opposite angles are always going to be supplementary. They're not exactly the same, but they do add up to 180. For this example, remember that the Pythagorean theorem is a squared plus b squared equals c squared for any right triangle. Given an inscribed square, so this square is inside of this circle. Because it's a square, remember that this is a right angle, this is a right angle, this is a right angle, and this is a right angle. So given an inscribed square with each side being equal to 10, what is the exact circumference of circle W? So all of these sides are 10. Because it's a square, they're all exactly the same. So if we want to find the circumference, we'll probably need to know either the diameter or the radius. So I'm going to draw in from here to here. This would be the radius. That one might not be as easy to find, but if we go all the way across, find that diameter, now we've created a right triangle that is also isosceles. So I'm going to draw that in with blue here. Here to here, here, and here. These two sides are both 10. Here is a right angle. So we can use our Pythagorean theorem to find out this missing length. That would be the diameter. So Pythagorean theorem tells us a squared plus b squared equals c squared. So 10 squared plus 10 squared equals the diameter squared. 10 squared is 100. So replace 100 in each of these places. Add 100 to 100 and we get 200. So 200 equals the diameter squared. And if we take the square root of both sides, we'd get that the diameter equals the square root of 200. So from here to here is the square root of 200. Now we want to know the circumference. Remember, the circumference all the way around is pi times the diameter. So replacing in the diameter, we'd say C equals the square root of 200 times pi. Or if you wanted it to be using the decimal, it's not necessarily exact, but using the decimal value would be about 44.406, going all the way around this circle. Another example here. Given a circle with the circumference being 65.4, find the diameter, then find the radius. A couple things to remember. Here are the circumference formulas. Remember, we can always use those. Also, a diameter equals 2 times the radius, or the radius equals 1/2 of the diameter. So let's look at finding the diameter. Circumference equals the pi times the diameter, or 3.14. That's what we use for pi times the diameter. It looks like here they're using more of an exact, or more of an approximate, the decimal. So we're actually going to get rid of this one. We're not going to use this one. We're going to use the 3.14 times the diameter. We're going to plug in 65.4 for our circumference. So 65.4 equals 3.14 times the diameter. Divide both sides by 3.14, and we get that the diameter equals 20.82. Once we know the diameter, then remember, the radius is just 1/2 of the diameter. So the radius, we'd start with the diameter. We know that the radius is 1/2 of the diameter, so the radius is 1/2 of 20.82. So the radius is 10.41. So now we figured out the radius and the diameter of that circle. Given this diagram, find R stands for radius, and find the exact circumference. So, again, it looks like we have a right triangle being made. Here, 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 and across. So we'd use our Pythagorean theorem to say that these two squared would be our missing piece, squared. So 12 squared plus 10 squared equals d squared. 12 squared is 144, 10 squared is 100. We're still missing this length, the diameter. Add these two together and we get 244 equals our diameter squared. Take the square root of both sides and we get that the diameter has to be the square root of 244. Again, we can't necessarily simplify that. That is an exact answer, so we'll leave it as the square root of 244. And we'll write in that the radius is going to be half of that, or the square root of 244 over 2. That would be our radius. And if we actually plug that into a calculator, then it would say that the radius is about 7.81. So that's just this distance here to here is about 7.81. And they want the circumference then, so all the way around the outside of the circle. Might be easier to use the diameter for that one. Remember, it's always just pi times the diameter is our circumference, so we can just write in pi times the square root of 244. That would be our circumference all the way around the outside. Given square GHJI with inscribed circle, so the circle is on the inside of the square, find the diameter, find the radius, and find the exact circumference. Well, remember, because this is a square, this is going to be, they're each going to be right angles. Also, this line is parallel to this line, and this line is parallel to this line. So if we were to take and draw in a diameter, right here. Oops, I need a curved line. There's a straight line right here. This figure that we've drawn in at the top is also still a parallelogram. We've got these two are parallel to each other. This is a right angle, this is a right angle. So by our properties of quadrilaterals, these also have to be right angles, meaning that this is still a rectangle. If this is a rectangle then, and this one is 18 feet, this also has to be 18 feet. This side here, which means our diameter has to be 18. Cutting that in half then to find our radius. Radius has to be 9. And to find the exact circumference, we can use one of these two formulas. And we would get, if we're using like pi times the diameter, well, the diameter was 18, so we'd get 18 pi is our circumference. Last one. Given the quadrilateral PLHR that is inscribed within the circle, find x and y. Well, remember, opposite angles, so like this one and this one, are always going to be supplementary for a quadrilateral that's inscribed in a circle, which means that y plus this 90, this is a right angle, has to equal 180. Subtract 90 from both sides and we get that y equals 90. So we figured out our y pretty quick. Similarly, this angle plus this angle have to equal 180 because they're supplementary. So we'd say that 14x, this piece, plus 8x plus 4, this piece, have to add up to 180. Combining our like terms, 14x and 18x become 22x. Subtract the 4 from both sides, and we would get 22x equals 176. Divide both sides by 22, and we would get x equals 8. And that'll conclude our first section of triangles.